Okay, what's up? I have changed my screen because I realized that the stuttering and drop frames were being caused not by the bit rate or my connection, but by the animated overlays I had, like the animated border around the entire frame, and then the border of the camera. So I took those off, and I think the stream quality is going to be better. Looks like I'm at about 15% CPU. Still at 1080, 30 FPS, which is perfectly fine for, not gaming. So we'll see how this works. Where are we now? Well, we've got the gain. Oh, I remember. The plugin wasn't showing up in Logic. Okay. So let's see if it's there now. Okay, got it connected to Logic. I'm gonna hit play, see what happens. And this first build is always going to take longer than all the other ones. Okay, Logic is opening, so let's see what happens. Just gonna look at the plugin manager first. Oh look, there it is, L utility. I think that's it. Okay, just want to make sure that wasn't too loud. I'm sure the oscillator was loud. So let's see. L utility. All right, let's see. The only thing we have implemented is the input right now. So let's see if that works. Yep. Perfect. Very cool. I'm gonna save that. So now we can start implementing the rest of the stuff. So let's do the filters. And I was kind of thinking before this, we want the and thinking in terms of the actual signal chain, we're gonna want the phase fixing part of it to be after everything that can ruin the phase. So let's do the filters next. And see, and we can start measuring the phase and stuff with plugin doctor. And yeah, we can see what kind of filter we need. I'll do a regular Iir filter first. Let's just go over to the process block, take a look at what we're doing. Yeah, we just have to block. Okay, so let's use a regular I guess we could do a Linkwitz Riley. Unless we do What I like about the Linkwitz-Riley filter is how steep it is. Our other options would be to make an IIR ourselves. We could use the ladder filter, which is cool, but it has extra stuff in it, like it has distortion and stuff like that, so might be extra CPU for no reason. So I think I just want to, let's just do the Linkwitz-Riley filter and see how it goes. So it's pretty easy. It's just a JUCE DSP module. So and then we're gonna make two of them, a high pass and a low pass. Okay. And we need to prepare them. I'm also gonna start using the reset call. Let me do that for the input gain. Reset first so that every additional time after the first time it will reset before it starts a new processing pipeline. Low pass filter dot reset, low pass filter dot prepare, pass filter dot set type. I assume this is in DSP. Yeah, filter type. This is, which one is this? Low pass. Okay. And then we do the same thing for the high pass. Oh. High pass. Okay. We're going to do the processing. Low pass dot process. And then we could just pass in the same audio block with the process context replacing. Then we can do this for the high pass. High pass filter. Okay. Low pass, high pass. Okay. And then we need to connect our variables. And I don't think we made these yet. Yeah, we need to make one for low pass and high pass. So this, the name is what you see in the DAW, and this ID is what you use in the code. So you can use something random for this one, but for the name, you're gonna want to use something that's actually descriptive. Okay. We're gonna need two of these, one for the high pass and one for the low pass. And then we also need to push those back into this vector. Okay. This is gonna be, that's the high pass. And I forgot, already forgot what our ranges are. So the low pass is, okay, so 250 and then 2500. Wait, that. Okay, low pass is the high cut. So that's gonna be 25 hundo to 20,000. And then this one's gonna be 20 to 250. Okay. Oh, you know what? I'm just gonna copy this. This is where we actually connect what the parameter does. So whenever it sees a parameter that's moved and it has this ID, we can do something to it. And in our case, we're gonna do highpass filter dot set cutoff, and we can just pass in new value, which is the value coming in. And we'll do the same thing with the low pass. We need a listener to actually listen to those changes. We can put that up here. And then we need to destroy those listeners whenever the plugin shuts down to clean up memory. Make sure there's no memory leak. Okay, and then we need to do the attachments. So yeah, this right here, we can just copy and paste this. Okay. Let's do low pass dial attach and high pass dial attach. And then where did I put that? Probably in UI constructor. Yep. So that low pass. Yep. Let's put it first. Oh, you know what? Set skew factor for midpoint. So this matters. The order that you put your attachment, set the range, and your skew factor matters. And I always forget. I'm gonna open up. I think my phone plugin does it correctly. So if I go UI methods constructor, maybe that one didn't need it. Oh, you know what? I bet the stereo widener I was doing had it. Okay, yeah, so you do your attachment first, then you have to reset the range again and then do skew factor. Okay. So this is low pass dial attach and low pass. This is going to be ID. Oh wait, LP ID. And then low pass dial is what it's attached to right here. I've been trying to make a plugin. Yeah, or if you got any links that could be helpful, I want to make a compressor like what's MV2? Oh wait, is that the one? Did you ask me about this already? Oh yeah, this is the one that looks like. Is it like a combination of compressor and expander? Is that what the low and high does? He's plugging it. Yeah. So what I would do, I haven't seen a compressor tutorial. I can definitely make one. I implemented a compressor based off of book by Eric Tarr called Hack Audio. Yeah, so basically the book, the table of contents is basically set up like the book is supposed to take you through making DSP plugins in MATLAB, but all of the MATLAB code can be very easily converted to JUCE code because it's just math. So he goes through a couple of chapters of the book or the link to the book. He also has a website for the book. Hackaudio.com. So here's the website. I'm not sure if you can, let's see, can you buy it from the website? Oh look, looks like he has some kind of tutorial in JUCE. Okay, so it looks like he doesn't have compression on the website, but if we go down to distortion and you go to clipping, there's some very simple equations that describe clipping. So I bet there are other things, stereo, yep, echo, filter. Yeah, I don't see compression, but it's in the book and it's not complicated. But probably what he's using Xcode though. I'm on Windows. Yeah, I mean, it doesn't matter. You can use Visual Studio. I mean, obviously they look very different, but I mean, you're writing the same code using the same stuff. What else was I gonna say? Oh wait, he has a GitHub. textbook code. Compression's towards the end. I'm pretty sure it's towards the end. Oh, look, here you go, compressor. That. Here we go. This is the actual compressor code right here. Yeah, and it's not, I mean, it's like 40 lines. Let's see. Okay, there you go. I dropped it in chat. Okay, what was I doing? Low pass dial. Oh, I gotta set the range again. Which is gonna be 2,500 to 20,000. Okay. That, and then we're gonna do the high pass. Yeah, no problem. That book is really good. Like, you could actually sit down with that book and work through the whole thing and just build a plugin for each one. I mean, it goes through almost everything that you would possibly need. It does stereo widening, gain, shows you gain conversions like logarithmic scales, RMS, stuff like that. Distortion, compression, chorus, flanger, delay, reverb, pretty much everything. Okay, is this ready to test? All right. I'm just going to go ahead and start testing the filters, see if they're even connected correctly. JUCE also has, oh, well, you want to make an expander. I think JUCE just has a compressor built in. So what I imagine is what you would do is there's a part in the code that says, you know, if it's above the threshold, divide it by the ratio, and then I guess for the expander you would say if it's less than the threshold you would divide it by the ratio, and then you could just make a button that switches between the two options of above or below. Okay, let's see what we got going on. High pass, low pass. Okay, that seems correct. Oh wait, the skew factor is not working. But it is for the high pass. Oh, because it has to be first. Why did I? Oh. Let's. Oh, wait. Wait. Attachment range, then skew factor. Attachment range, skew factor. Why is that not working? Attachment range, skew factor. Low pass dial, attach LP, cut off, low pass dial. It says skew factor from midpoint. Why is the... Oh, well, for one, I don't know, that's kind of weird. I don't know if that's really the issue, but it definitely shouldn't have been like that. Let's see if we fixed it. I think we did. It looks like our high pass isn't initializing correctly. I think I want to put 10,000 in the middle. That makes more sense. Okay, so low pass 20 to 250. So why is it not initializing correctly? Oh, that's probably not good. This one also. Come on. All right. I'm going to open it and take the plugin off the track. So that we can know that when we put it on, it's initializing as it would if it was brand new. So we can check and make sure that it's actually initializing correctly. Okay. Okay, that was... It's still not initializing correctly. Oh, I know why. I bet I didn't, yeah, I didn't put it in, yeah, I need to put it in here. Okay. So I need to go and take this, set cutoff for both of them and put it in the prepare method so that it gets called before audio starts the first time. So that's the high pass. Low pass, set cutoff frequency, and then this is gonna be the value in our value tree. Get raw parameter value, and this is LP ID. Okay, and we could do the same thing for the high pass. And then pass it high pass ID. Take a nap, catch you later, my guy. All right, see you later, my guy. Wait, what time is it where you are? Oh, so, okay, 6 p.m. Okay, just wondering. Cool. I'm gonna turn it up a little bit so I can hear it better. Okay, I just want to make sure the high pass is actually doing it. Okay, good. So that works. I'm gonna not save. I want to open it with Plugin Doctor. And kind of check out the phase. I'm not 100% sure what I'm expecting, but I just want to check it out. It's called L. Wait, is it this one? Yeah, okay, it's that one apparently. Okay. Cool. Filter looks like it is doing what I thought it would. Okay, let's check out the phase. Okay, so the phase, okay, so good. I just want to make sure. This is what I expected, but I wasn't positive if I was correct. So what we could do, I'm thinking we could put in a linear phase option that just changes our filters from those LR filters to FIR filters. We could do that, or we could just say, we could do that, or we could just say, have the user play around with the phase knob. But I'm not sure that's really enough. I can try something really quick. I'll just flip the phase of the buffer and see what it does. Let's see, go into my code bank. I'll do a block loop. And I'll say data sample. I'm just gonna do times equals -1, just to flip the phase after the filters, and I just see what it does. I don't know if it will actually do anything, if it'll retain the same phase issue just flipped. I just kind of want to see. Interesting. I don't know what this realization tells me. I'm gonna implement 2 FIR filters and see if that changes anything. Or let's just think about this for a second. So you filter the signal once, which delays it by a certain amount. Then you filter it again. Well, what if I flip the phase after the first filter and the second one? I think usually the phase issue is more of the high pass filter, not the low pass. I could be very wrong about that, but I think the high pass filter has more of an effect on the phase than the low pass. Okay, so it helped, I think, a tiny bit. But yeah. Okay, so let's delete these. And let's do FIR filters, which I actually haven't done before, but I watched the audio programmer, watched a video a couple minutes ago that I missed apparently. Missed a long time ago. Actually, you know what? I'm gonna try to do it without looking at his tutorial. Okay, so you do a processor duplicator, like you would an Iir filter. Type I think float and then FIR coefficients, and then that would be filter 2. Sure, let me look at this real quick. That's the multiband. That one doesn't use a processor duplicator. Oh wait, what does this use? Yeah, it uses the LR filters. Okay. Do I have something recent that uses a processor duplicator? A phone? Yeah. Processor duplicator. Oh, I'm stupid. Okay. It's, yeah, okay. Wait. Yeah, the FIR filter. Okay. And then coefficients after, yes, okay. So that, then in the constructor, we say, what did I just do? High pass filter. Okay, high pass filter 2. And we do JUCE. I think it's filter design. Wait. DSP. Filter design. Float. Design. Let's see. Let's do window method. Yeah, let's do window method. Frequency. Our frequency isn't set yet at this point because the constructor is first. This is the high pass, which means a low cut. So let's do 20. Sample rate, 44,100. Order, I'm not 100% sure. Let's see. Filter design, window method, order, the order of the filter. Okay, whatever. But in terms of FIR, I don't think the order numbers are the same as IR filters. He used 21 in the video, so I'm just gonna put that too. And then windowing method, where's window method? Wait, where is windowing method? It's in filter design. And then we'll use the hamming. And that's it. Let's see if it builds. Okay, it builds. Okay, so apparently that's the way you do it for an FIR. So I guess I could do the low pass now. Low pass, low pass, low pass. Okay. Do the same thing. This is gonna be low pass, 20,000. And I guess I'm gonna use the same. Yeah, okay. Same windowing method, order, blah, blah, blah. So let's go down into prepare, and we can say high pass filter 2. Yes, it has a reset method. I'm sure it has a prepare method. And then we need to set the frequency. No, we don't. No. So we're gonna make, what we're gonna do is we're gonna make a update filter method, and then I'm gonna call that method in the prepare play. So let's just do the same thing for the low pass. And I'm gonna actually move these up to stay consistent with these right here. And then we're gonna go into here, and we're just gonna call low pass filter 2.process. Do the same thing for the high pass. I'm going to comment these two out. And then we need to make an update filter method. Okay. So I'll put some space between these. Update low pass and high pass. Okay. Gonna take this and actually implement the methods. Update low pass. And then we're gonna say low pass filter 2 dot state is equal to JUCE ESP filter design low pass float frequency. Okay, so we gotta pass it the frequency. Okay. Const float freq. That here. And then do I have a sample rate variable? Doesn't matter. I'll just say get sample rate. I guess I'll say 21 again. I'm gonna pull that windowing method thing from the top. And I just realized I did design low pass and low pass. Okay. Oh, where is it? Right here. Now that I think about it, is there a high pass? Design. Oh, there is a. Oh, wait. Oh. Okay, so there's only a low pass. So does that mean I just subtract the low pass from the input and that's the high pass? Before I get too far ahead, this is low pass, right? Low pass. So in the low pass, okay. Update low pass filter, and we're gonna pass it new value, which is the cutoff. Okay, so let's make sure that works just with the low pass. Okay, here we go. You know what? I gotta go to the processor and I gotta comment out the high pass because we haven't set it. Well, I got some weird artifacts. Wonder. Okay, yeah, I got weird artifacts. But anyway, something we could solve later. Let's actually see if there is a method that I'm not calling. No, I mean, all it has is reset, prepare, and process. Hold up, am I doing something in here that's not? I guess it could be the order, but I'm not 100% sure what it does. Let's see what plugin doctor says. Okay. Oh, that's interesting. I'm gonna mess with this order button and see what happens. Okay, so that order might be a bug. A direct form discrete time Iir filter of order in. Oh, great karma. Okay. The order of a filter defines the order of the transfer function. Order the polynomial, thus the equation, the order of general. Oh, that's not very helpful. I don't understand that. Yeah, I don't know about all that. I'm just gonna put some random stuff in here. That seems better. Okay, it doesn't like 3. Okay, it doesn't like 4. Doesn't like 5. Only 3 more options. Okay. It'd be really funny is if 8 doesn't work and then I try 9 and 9 also doesn't work. And I've just been doing this for nothing. Okay, oh, 8 works. Okay, this is good because, okay, so the phase is static, whereas if you use an Iir filter and do this, the phase will be moving around and changing with the cutoff. And it kind of is at the top, but I mean, not where it matters. Okay, this is interesting. I kind of like this, how there's a little bit of area around, I don't know, 15K that isn't cut off, and then has a little bit of slope. It's kind of realistic and analog, so I kind of like that. Also, the way it moves, the amplitude changes a tiny bit. Like right here, you kind of see the line kind of very subtly dip a little bit. I don't know, it's kind of cool. So as far, that's low pass, so high pass. Actually, let me pause and I'm gonna go get a drink, and I'll be right back. Hope this scene change works. I'm back. Okay. Okay, so the high pass. Okay, wait, we can do process sample. So maybe instead of doing process like this, maybe I'll do a sample or a block loop. Okay, so what we do is we say const float input is equal to data at the current sample. Okay, and then we can say the high pass is equal to the input minus wait, why can't I do process sample? What's up with this? Well, that's unfortunate. Low pass filter 2 is, yep. Yeah, I don't what the hell? Oh, I know why. 'Cause I should really be looking at processor duplicator, right? And it just has a process. Okay. So then the problem would be I don't think I can do this in the sample loop. I think it'll do weird stuff. Yeah. Well, then this method's just not going to work. Well, these Iir filters, like if I go to where would it be at? Okay, Iir coefficients. I say make and none of these say minimal phase. I'm wondering what these first order ones, they don't really say anything about them. Okay, this method is just not going to work with the processor duplicator because you can't process sample by sample in the duplicator. Well, I guess I could use another buffer and add them together. That's going to be a lot more CPU. All right, I'm just going to go ahead and get rid of these. Get rid of that. Get rid of that. Get rid of these. That. Put that back. Get rid of those. Oh wait, hold up. Yeah. Get rid of those. And then Is that it? Oh, I don't need that comma. Okay, let's make sure this is still working the same way. Okay. Yep. Too bad the phase isn't linear. Well, the phase at the top is actually okay if you're not doing too much with it. But the bottom, or I should say in between, they get real hairy. And it really looks like you could just flip the phase before and after and it would be fine. Or it would actually, or it should at least shrink. And I know we tried that already. I'm gonna do it again. I'll do it again. Okay. A block loop. And I'm just gonna say okay, so I'm gonna copy it and put it in the clipboard. And just build it and see what combination works. I think that's actually worse. I'm basically just going to try every permutation. See if anything changes. Okay, so now I'm going to put one after each filter. I just tried flipping the phase once. So now we can flip the phase twice. And check each permutation of that. It'd probably be faster to set up like 3 buttons to do this, but oh well. It's about the same. And then what else could we do? Flop, flop. Yeah, like that. Okay, now, since that doesn't seem to be doing much, I'm going to implement the variable phase with JUCE's DSP class, and I'm going to try that in between them and see if that works. Let's set up the dial first. So variable phase. Okay. Oh, mapping this parameter is going to be interesting. This is going to go from 0 to 360. And I think we're going to start at 0. Okay. And is the dial set up for... Yep. 0 to 360 by 1 starts at 0, or resets back to 0. Okay. So I need to make an attachment. Variable phase dial attach. And then the phase dial. Okay. All right, and then we're just going to implement the JUCE DSP phase. I haven't used yet, but it looks simple enough. returns the current value and increments the phase by the given increment. Okay. Okay, so this goes between 0 and 2 pi, so we got to map 0 to 360 to that. So I guess I'm just going to make a private variable called, oh, you know what? Let's make a 2 pi variable. Wait, I forgot how to use the fast math thing. Oh no, that's not the one. What am I looking for? It's not in DSP, it's called math constants float, I guess. Is that correct? Okay. And then if parameter is var phase, we are gonna map it auto phase is equal to JUCE JMap, which is like a scaling algorithm to scale two numbers to two other numbers, or a range to another range. Source value, which is new value, and they all have to be floats. So source min to 360. So we're mapping 0 to 360 to 0 to our 2 pi thing that we just made. And then we're gonna call variable phase module dot advanced. Then we're gonna pass it in phase, I suppose. So that's that connection. We just need to prepare it. Dot prepare. Oh wait, is it reset? Okay, well apparently we don't even need to reset it. And then I'm gonna just put it right here. Oh. Okay, this is what we need to do. I'm gonna make another variable. Current phase inc. I guess I'll just set it to 0. And then what I'll do is take this out of here, and I'll say phase inc is equal to that. And then now I can go put this advanced function where I want it in the process block. Advance and then the phase inc thing. So I'm gonna put this in between them. so that the first time we look at it, it'll hopefully be obvious what's happening. Okay. Let's make sure that the dial is actually giving us something. So we'll debug current phase ink. And we'll run this with logic so that we can look at the console output. And if our dial is indeed giving us values, I don't really know where to go next. Not really doing what I expected. Okay, so I'm gonna move the dial and see. Yeah. That should be 2 pi. Yeah. And that should be 0. Okay. So maybe I'm using this incorrectly. Oh, I bet this is meant to be used with an oscillator. Well, you know what we could do is use an all-pass filter. Let's see. Actually, let's go to a new tab. No graph? Really? Oh, wait. This looks exactly like my using all pass filters. Dual 12-inch two-way. This isn't the graph I was looking for, but that gives me some hope. What I was looking for was okay, whatever. I mean, this is good enough. Basically, at increasing frequencies, your phase is going to change. Wait, 100, 150. Yeah, okay. So I think what we could do. This is really interesting because this looks exactly like the problem. So let's. Let me think about this for a second. So our processor does input gain, which is virtually no delay on paper. And then it gets delayed by this low pass filter. Oh, is this what I was looking for? This is more what I was expecting. Okay, yeah. All right. Let's get rid of this phase. And let's make, instead of phase, we're just gonna make another LR filter. This is gonna be, I don't know if I'll need one or more, but let's just say low phase filter. And then we're gonna go, I don't need to do anything in the constructor, right? Nope. And go into here. Okay, it's gonna be an all pass, but this is where we need to make some kind of conversion. So we're gonna need see, the low phase filter is gonna go with the high pass. So I don't know, just set it to 20 by default. And then what we'll do is in a variable phase, we'll say phase cutoff is equal to JUCE JMap source value, which is new value. And that's coming in 0 to 360. And let's map that all the way to 20,000. Just as an experiment. And and then we'll say low phase filter dot set cutoff low phase cutoff. We're gonna need to do the same thing in the prepare method. Hold up. This is what we need right here. Instead of new value, it's going to be our var phase. That's 0 to 360. Cut off, and then we put the low phase cutoff here, and then we don't need this. I kind of want to set the type before, and then oh yeah, this we need to cast it to a float. That should work. Okay. All pass 0 to 360, 20 to 20,000 in our all pass filter. And I think I'm gonna put it in between them. I'll try that. Okay, let's try that. Interesting. See if that's any different. Let's set this to a reasonable value. You know what? These Linkwitz Riley filters, where'd they go? I can process individual samples. So okay, let's check this out. I want to see what the phase does with just the low pass. check out just the low pass with the phase filter. Yeah, I think it helps. Now I'm wondering, maybe we can just use two phases. So have a low pass phase and a high pass phase. Okay, what if I don't have this phase button? I already forgot what it's like. Or this phase dial, I mean. Because it looks like I don't even need to be able to control it. I might just need to set it. Okay, so at about 2000 it goes straight up and then out. Is this better at 20,000? I don't even remember. A lot of back and forth in this process. No. It's not any better. Yeah, it might not be necessary. Because let me pull up, let's see what a good well-known plugin does. Do I really have anything? Well, this is the wrong folder. Not doing anything. Which one is Neutron? Okay, good. Okay. Okay, interesting. So that's what the phase is supposed to look like. Probably. Is there a linear phase option? Okay, so that gives me an idea of what it should look like at least. Yeah, I don't know. I'm gonna have to figure that out. But I guess this is where I'm gonna stop. I'm gonna let this close real quick. Thanks for watching. Really appreciate it. Be back tomorrow at 5:30. Same thing. And see ya.